Okay, so we're gonna start simple, and then I'm gonna build back up. So when we talk about Iupac, nomenclature. So we have what we call inorganic, and we have organic. The rules that you learn in inorganic aren't going to apply completely to organic. And that's something that you need to understand right now. Organic has its own little set of rules because the compounds are going to be very long and things like that. So we have to pay attention to those rules in addition to the rules that we have in organic. Okay. So the first thing is that we need to do is define what is organic and what is inorganic. Okay. So organic molecules are molecules that basically have carbon in it. I know that you guys were, when you talk about organic vegetables and everything like that, you're like, oh, it's grown without any pesticides and all that stuff. Really? That was something that the media essentially made up for you, right? Organic basically means that it has carbon, right? So molecules that have carbon in them, so like, for instance, even though we have carbon dioxide, technically it's considered to be organic because it has carbon in it. But we tried to draw some lines as well. So things that are basically carbonate or carbonic acid. Okay, carbonate. So these guys, even though that they have carbon in it, organic chemists don't consider that to be organic, right? So, but the general definition are things that are organic. So for instance, if we have methane, CH4, that is considered to be an organic molecule. Okay, so does that make sense so far? These guys are exceptions. But anything else that has carbon in it is considered to be organic. Okay, so when we go with nomenclature of these molecules, we have what we call, we have to pay attention to the number of bonds. So if we have a carbon chain, say C, that is just we do a lot of naming of carbons based upon the number of carbons that we have. So we want to always try to find the longest carbon chain that we have. So in this case, how many carbons are here?
3.
We have 3 carbons. Can I erase these exceptions right now? Maybe I should just move this to another page. Sorry. Okay. The first thing is that when things are all single bonded, you have only single bonds and you have hydrogens that are occupying all of the spaces that are able to be occupied, it's considered to be saturated. So this guy is considered to be saturated because it's saturated with hydrogens. So there are no double bonds, okay, or triple bonds, okay? So anything that doesn't have any double bonds, and it has a carbon, it only has carbon and hydrogens, these guys are all called hydrocarbons, first off. So this would be called the hydrocarbon because it has carbon and hydrogen. This guy here belongs to a family that we call both of these guys. So in this case, for CH4, and for this would be C3, H8, right? So this is how we would write the chemical formula, right? This is how we would give us an expanded model of that chemical formula. And these guys, both of these guys belong to what we call the alkane family, A and E, okay? So that A and E basically means that everything in there has single bonds. There are no double bonds, okay? We would name it based upon the number of carbons that we have in our longest chain, meaning 1, 2, 3, right? This guy only has 3 carbons. So this guy would be called propane. You've heard of propane before?
Yes.
Yeah.
This guy here is called methane, which is the chemical structure is like this. And I'm gonna erase this here, my exceptions.
And just to clarify, Dr. Henry, those exceptions were not organic, right?
They're not considered to be organic. Even though they have carbon in them, they're not considered to be organic. Organic chemists don't want to include them. They're elitist. Okay, so now it's always going to be based upon numbers. If we have 1 carbon, this guy has 1 carbon. 1 carbon means we start off with meth. 2 carbons, that's going to be eth. 3 carbons, that's going to be pro. 4 carbons, that's going to be bute. 5 carbons, that's going to be pent. 6 carbon, that's going to be hex. 7 carbons, that's going to be hep. 8 carbons, that's going to be oct. 9 carbons, that's going to be known. 10 carbons, that's going to be dec. 11 carbons, undec. 12 carbons, dodec. Okay.
Sorry, what do you call these? Like how there was Romans prefix. What's this one?
So this one is kind of a mixture of both. It has a little bit of Greek. If you notice the last part, the pent, the hex, the hep, the oct, all of these are Greek, but these beginnings aren't. I don't know what in the hell where they came from. Yeah, telling you the truth, right? That's that's going to be an interesting class if they ever get a history of science class, because some of the names are like crazy, you know.
Dr. Henry.
And how they got some of those names, I'm telling you, there's a lot of drugs that were going on. Not just because it's chemistry. Now, what was that, Nate?
I said they're gonna call the class Dr. Henry tells you where meth comes from.
I know, huh? Yeah, I should expect that call any day now. Huh?
So methamphetamine means it has 1 carbon in it?
Yeah, so it's the branch of it, it's meth, and then amphetamine. Amphetamine is it's a branching of carbons, but you have a methyl group on it, and you also have an amine group on it.
Wow. The
Yeah.
more you know.
Yes, and see, this is how a lot of the drugs, their actual drug names, it comes from this part because a lot of them are organic or are organic molecules. Okay, so you always want to try to find the longest carbon chain. 1, 2, 3. So that means that we would call this guy propane. Okay, now, I don't know about you guys, but if you have to write down 11 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? And then I have to put all of these H's on them, right? That gets a little tedious. Okay, so what we've done is we use what we call these line structures or skeletal structures. A skeletal structure is just taking into each point representing a carbon. So that would be 1, 2, 3 carbons, right? And then they're saturated with hydrogen. So they could have any of the bonds that are available. So in this case, this guy would have 3 bonds here that were available. All of those would contain hydrogens. So we wouldn't have to write the hydrogens. We understand that they're saturated with hydrogen. So it would be the same thing as this structure right here, but we just drew it as this little hat, you know, carrot.
And how
Okay.
do we put the H's on them?
Okay, but you don't. The H's are understood because it's a hydrocarbon, right? So it's understood. So all you're using are the points. So that's 1, 2, 3 carbons, and then they're saturated. So they hold as many hydrogens as they can hold. We know that every carbon can hold up to 4, have 4 bonds, right? So if we take a look at this, 1, 2, 3, 4, that means that there's 3 hydrogens here. This guy has 2 hydrogens because there's 2 bonds with the C here. These guys have 3. And so by us drawing the structure, we drew exactly the same thing. Look how fast I drew this compared to how long it's going to take me to draw this. Right?
Can you say that again?
Wait, so if
Okay.
you were writing 5, it would be like a M hump?
So
Is that
yeah, exactly. So if I was writing 5, let's say we were writing, let me move this real quick. Slide this over. So if I was writing C5, and that would be what, 6 plus, I have to do the math to get the number of hydrogen, right? 6 plus 3 times 2. So that's 12. Okay, so I could actually write it all out with, in this way with the structure, or I could write it out as 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that would be the same thing as that. Or I could write it out as C, 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 C,
no one wants to do that?
C. Exactly. So that's the reason why we use that skeletal structure.
Can you
Especially when you're
explain?
doing it via Zoom, it sucks.
Can you explain
And
to me
that's for the
again what a
carbon?
hydrogen?
What was that? Can I explain what happens to the hydrogens? Or how do I account for the hydrogens, or how do I get the hydrogens? Is that what you're asking me?
Yeah, can you
I'm
explain
asking
that?
where are the hydrogens in that M structure?
That M structure means that they're understood, right? So because we're working with what we call hydrocarbons, right? Meaning that they only have hydrogen and carbon in them. So that means that we know that carbon has 4 valence electrons. So we know that carbon, when it's saturated meaning that it's going to occupy all of the bonds, it's going to bond completely with hydrogen. It can only have 4 things attached to it, right? 4 in this case, in the case of methane, it's all 4 hydrogens, right? In the case of this guy would be called pentane. You have hydrogens occupying every spot that is not being occupied by a bond with another carbon. Does that make sense? So we have
So the
5
first and
carbons.
last would be 3, and then everything else would be 2.
That's right. And so that's what I was calculating. So that's 3 here, that's 6. And then there's 2, 4, 6. So that's 12.
So the bonds between the carbon, you're not, those are what the lines are already indicating. All right,
Exactly.
I got it. That makes sense now. So we
Okay.
could take, it was like decane or something like that, and there was 10 of them. It would be like, you'd count for 6 for the ends, and then 8 times 2 would be 16. So there would be like 24
That's right.
hydrogens. Oh, that's easy, man.
That's
All
right.
right.
Okay.
It just clicked.
It takes
My
a
last
minute.
fired. Yeah, it just fired
So-
off right now.
So the thing is that when there's only single bonds, we use that word ANE, right? So that lets us know that we only are working with single bonds. We're working with hydrocarbons that only have single bonds. And so that lets me know how many carbons I'm going to have. okay? And and then from there, you can sit there, either you could draw it all out, or you can sit there and do it, as long as you know that it's a linear structure, meaning that there's no branches going off of it. We'll talk about how you handle the branches here. So,
Is
okay.
it safe to say only group 1 would be able to do this?
Oh.
Like with the A name at least?
What do you mean by only group 1?
Like carbon attached to something from group 1.
Okay, we will get to that because those are special, because group 1 is, you're making reference to the periodic table group, right? So,
Yeah.
So that would be an ionic compound, right? We're not talking about ionic compounds. We're just talking about organic compounds. So these are just hydrocarbons right now. So we'll talk about how they interact with each other, with how you get organic and inorganic coming together, right? Because a metal is considered to be inorganic carbon.
So so the little N structure, can you only do that with hydrocarbon?
Yes, so you can do that with hydrocarbons, yes. And then you can do it with hydrocarbons and other things together, right? But we will talk about how you'll go about that process. I'll build you up to it, okay? So are you guys ready for the next part? How you feeling so far with the A and E?
Okay.
Too bad.
Okay, so anytime that you see A and E, you're knowing that it's all going to be single bond, okay? So I'm going to add on, first I'm going to copy this so I can bring it to my next page. Okay, so the next one that we're going to be talking about is E and E. Anytime that you see that word E and E, that represents a double bond, right? So that means that we have carbon double bonded to other carbons, right? It can be one double bond, it could be two double bonds, it could be three double bonds, it could be four double bonds, you know, but that E and E means double bond. But we have to tell people where those double bonds are at, okay? So like say we have this guy. And I'm going to draw it completely out, and then I'll show you how to draw it stick structure in a second. Okay. So this guy, according to Iupac nomenclature, not common nomenclature, but Iupac nomenclature.
Dr. Henry,
Yes.
does Iupac have like what it stands for?
Yeah, it does. I'll have to get that for you. It's international. I can't remember. It's international something, and the last person, but it's all in French. So.
Oh, okay.
Yeah, I'll pull it up for you. So. Okay, so what would this guy be called?
Ethane.
That's right. So this guy would be called ethane or ethene?
Ethene.
Ethene, that's right. Okay, we know that ethane, it would be
A single bond.
that's right, would be a single bond filled with those hydrogens, right? Okay. Thank you. Actually, it all should be in French though, but that's what the answer in English. Okay. And that's the reason why we call it Iupac, right? So, because you don't want to have to say that all the time. Okay. So anytime that you have the double bond, right? You sit there, you also have to let us know where that double bond is. It doesn't matter in the case of ethane because there's only one place it can be, right? But the way that we would draw it in this case is just a double bond, right? Okay. And then that would represent the double bond. Okay. So if I have this structure, 3, okay, so this here represents a double bond, and we would have to count the number of carbons that we have and also where it's located. Now you always want to count it so that the main structure or the main functional group, in this case, the double bond is our main functional group, has the lowest numerical value that you can have. Okay, so let me go through that. So if I count it from this side, it'll be 1, 2, 3, 4, 5, 6, right? If I counted it from the other side, it would be 1, 2, 3, 4, 5, 6. So we want where that double bond is located to be the smallest value possible. And you always start with the carbon that it starts at. So in this case, we would name this guy. What is a 6-carbon structure called?
Hex.
Okay, so we put hex. And since there's a double bond in it, we'd put ene. And then we'd have to say where that ene starts at. So we'd put 2. So that 2-hexene tells me that I have a double bond located on the 2 carbon. And we started the structure with the blue, not the pink.
Wouldn't you just draw that the other way then?
You could just draw it the other way, but sometimes you get it drawn both ways to kind of throw you off, or, you know.
Like just for fun?
Yeah, just for kicks and giggles.
Like
Well, not just for fun. It's just that sometimes how people think about things are a little bit backwards, right?
Dr. Henry, I missed the part where you put the 2 before the hex. What do you mean the 2 goes there first?
Because that's where the double bond starts at. It starts on the 2
Oh,
carbon.
okay. Okay.
Dr. Henry, I'd like
And then
like
in
to use that.
structure, since there's 6, it would be it would begin with hexene then.
That's right. You count the longest carbon chain, and then that gives you your root. That's going to be the back of it. Okay, so you always want to get your longest carbon chain. This is going to make sense here once we start getting branching. Now, what was that? Somebody asked.
I was just gonna say, if I drew it backwards, it would still be correct, right? Like if I drew one line and then put a double.
Yeah,
and
that
then
would have been fine.
3
Yeah.
lines.
Long as it's on the 2nd carbon, yeah. And so you always count your carbons, right, to find the main structure, the main functional group, because there's going to be multiple functional groups that we're going to be looking at. Now, the main functional group has to be the one with the lowest number. Okay, does that make sense?
Yeah.
So as soon as it has that double line, it automatically gives it the ene, right?
That is correct. If it's only
And the hex-
hydrocarbons, right?
Yeah, and then the hex comes from how many carbons there is.
That's right.
Does it
Okay,
change the
yeah,
way
I
you count
see.
the hydrogen?
Does it change the way that you count the hydrogen? Yeah, of course, because a double bond here, like for instance here, a double bond has how many hydrogens left on? Because those carbons only have the ability to have 4 attachments. If 2 of the attachments are being used between the 2 carbons, then that means there's only 2 left. So this guy has CH4, where this guy has CH6. Let me see.
Right. So like if you were to count that 2 hexene chain,
6.
right? You would
What's
count
that?
3 carbon or 3 hydrogen at the beginning. Then
That's
you would
right.
count 2, 2, 2, and then a 3 at the end.
No, so you'd have 3 carbons here. You'd have 1, 1, 2, 2, 3.
Oh, you would count 1. Oh, okay. Why would you count 1? Because when I look
Because-
at that double bond of ethene, I see 2 hydrogens on each carbon.
That's because there's not another carbon it's attached to. So on this side, it also has another carbon, right? And so we have a total of 6 carbons, right? So this is the 2nd carbon. Here's the 1st carbon. That guy has 3.
So that's number 1 right there.
Okay, so that would be my 1st carbon, right? This here's my 2nd carbon. That guy has 1, 2, 3, 4 attachments right there for 4 bonds, right? And then this guy has
1, 2,
1,
3,
2,
4.
3, 4. Then this guy
Okay.
has, put them both here. 1, 2, 3, 4. And then this guy has
And these only are able to have 4 bonds because that's what completes the octet for each combination.
That's right.
Right.
So that's why it's important to remember that, right?
I was about to ask about the Octet rule. Do they still follow these then?
Yeah, look, 2, 4,
Each one of
6,
these follows the octet rule.
4, 6,
That's
8.
why you can only put 1 hydrogen on there. Because if you put 2 hydrogen on a carbon, then it would have 5 bonds instead of 4, and it would violate the octet rule.
That is correct. Okay. Pretty good so far?
Wait, so Dr. Henry, this little structure you just drew, that being a pentene, where is that? That's the 6th one that you just drew with the 2?
Wait, I guess I forgot one. 1, 2, 3, 4, 5. I have one more, sorry. One more carbon. Oops.
Okay, so once you do that, that's going to be the actual hexene.
Yeah. Good eye, good eye. I knew I was cutting it short somehow. Okay, so that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's
1 double
so,
bond.
and you see the difference, and you don't have to keep track of all of the H's, right? In this case, it makes it so much easier. So the skeletal structure makes it so much easier for us to see. Okay.
So on
Yeah,
the
that looks
scale,
great.
so like what you have in pink,
It's
like
the one,
you-
yeah, the line, the green line's down here. That's your skeletal structure.
yeah. But then what's the? I kind of missed that. The ones, like I see the
This one here,
pink.
this is
and
called the expanded
what's the
structure.
blue?
The blue is called the expanded
Okay.
because you're expanding everything out. You're writing everything out. Okay.
Yup.
Okay, so let's see those skills. I'm gonna erase these guys, and I'm gonna put some other ones up. Maybe.
Dr. Henry, if one day, if I was able to take a class of organic chemistry, this is what I will see one day.
Yes. No, this is what you'll see when you take a class with organic chemistry. No, I'm doing this just for the hell of it.
Yeah. Well, no, I'm asking this because I'm eventually looking forward to take that class later on, but not right now.
Don't worry, you will.
Oh yeah, it's part of my major. That's why.
Yep. And we're trying to get it offered at Kalinga, so now let's do this right here. Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. That's the double.
He wants to draw the expanded version.
No, I don't want you to. I want you to tell me the name of it.
Oh, okay. Now or just write it down.
4 nonene.
Yeah, nonene.
Okay. So we have, you did your counting. You said 1, 2, 3, 4, 5, 6, 7, 8, 9. Would that be the right way of counting?
No,
1,
No.
2.
because the
3,
double bond is
4.
close to.
Yeah, with the purple writing is better.
Okay, so we know that the purple writing would be the one. So it would be, you said 4, nonene, nonene,
Nonene.
nonene, nonene. Okay,
Once again, 4 means that's where the 2 bonds meet, right? In number
that's
4.
right. That's where the bond will start
Oh, okay.
on the
Now I
4th
get it.
carbon.
That makes sense.
You count from the shortest side, Alan. I think so. Like instead of counting 1, 2, 3, 4, 5 left to right, it's closer if you go 1, 2, 3, 4 from right to left. So
That makes
you
sense,
name it
yeah.
the shortest chain of to the double bond. Is
Yeah,
that
I
right,
get-
Doctor?
That's correct. Okay,
So
what
the
about this
second
guy
one-
here?
Is it one butene?
Okay. So
Aren't
how many
these-
carbons do we have? 1, 2, 3, 4. So it's 1 butane. Butene. Butene. That's right, butene.
Dr. Henry, these are all gases, aren't they? Propane, butane, pentane,
Some of them are.
methane.
The
Isn't
more
that all
carbons, the more carbons you have on it, it starts getting heavier and it becomes a liquid. Right? So there's the pentane is kind of like that breaking point. So when you start getting to hexane, hexane is actually a liquid. And then heptane and stuff like that. Pentane, depending on who's it with. So, and the temperature.
But don't they use a lot of these for combustion, like fuel?
Yes. Well, all of them are going to be used for combustion. We'll be talking about that here in a minute.
Oh, okay.
Or can be used for combustions, whether you like it or not.
I accidentally went ahead. My bad.
Yes. Okay, so are you guys feeling pretty confident on that so far?
1, 2, 3, 4.
One more, please. Just
One more?
Yeah, one more.
One more. Okay, so let's see. Let's do. That's not that one. Let's do this one.
Three, 4.
Okay.
I got it. I think.
Hexene.
You said
Hexene.
hexene?
Hexene.
3 hexene.
1, 2, 3, or 1, 2, 3. Oh, works out either way, huh?
Okay, so you're counting the number in front of
Three.
it is what it gets to where the double is. Is that correct?
That's right.
And you want to go from the shortest direction.
That's right. So this is
Yeah.
1, 2, 3,
Oh,
4, 5, 6, right? Or if we go it the other way, I think it'll be the same. 1, 2, 3. Yep, so it's the same either way. 4, 5,
Yeah.
6.
I see.
Okay, so again, the root or the base, the last thing at the end, is always going to be the longest carbon chain. This is going to be important later on. So you always want to try to find the longest carbon chain. You guys are with me so far?
Yes.
Okay, so let's go to the next page. Okay, the next one that we're going to be talking about is alkyne. Alkyne are triple bonds.
Ooh,
So
yeah.
like the same way that we did before, the triple bond, let's see if I- the triple bond is the major functional group when it's all by itself. Okay, so what would this guy be called?
2 heptine.
Okay, so let's, oops. So that's 1, 2, 3, 4, 5, 6, 7. So you said 2
Heptine.
heptine. Okay. That's 7. Okay. Let's see. What about this guy? 2, 4.
So it's the Ein. That's the 3.
The triple bond. Yep. And so, and also I should probably draw this correct. So triple bonds are typically, they're going to be linear, and then it's going to be the next group afterwards, because it won't be able to bend. And then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we'll do this one first, and then we'll do this one. So this guy is the typical way that you draw it, because the triple bond has to be linear with the next carbons that are adjacent to it. Okay, so it'll
You
be,
count that at each end?
what was that?
You count that triple bond at each end?
Yeah, so you count it here. I'm gonna draw it in green. Then you count it here, here, and then these would just be other carbons right here. You get that? So that's a carbon and a carbon right there.
And there's one at,
So
The
both
end-
sides of the bond.
Yeah.
and then
So in
one-
reality,
one-
because this guy's going to be a linear structure, this would be incorrect. So this guy should be. Let me fix it. It should be
So
really
it
like
should be
this.
like it should be an M straight W.
And
Kinda.
yeah. So that, and then you could go, then you'd get the fluctuation between. And then on this side, this guy would be linear, and then you get the fluctuation. So this here represents, this is that carbon there, and then it goes. All right. And so it'd be
So
like
that symbol underneath is wrong.
1, 2. Yeah, so technically this would be wrong because it forms a linear structure. So let me fix that.
That one on the top is only 4 from the right. The one below it was 5 from the right.
Yeah, like if that was the answer, it would have been
1, 1, 2, 3, 4, and there we go. Is that right?
Yeah.
Okay, there we go. Okay.
so then
that's-
it's just 4, not 9.
So that's, let's count it. That's 1, 2,
That would be 5, right?
3,
5 decine.
4, 5.
Yeah, I got 5 decine as well.
6.
Decine.
You count it
7,
on each side of the triple bond. So like normally that would be bent if
9,
we were doing
10. Okay, so if we count it from the other way, it would be 1, 2, 3, 4, 5. So it's the same either way, right? So this guy would be called, you said 5.
decine.
The sign.
Decine.
Wait,
Fine.
you said it's 5 because that where the triple bond is, that's like 3 or 4 spots in the middle instead of
Yeah.
just
So you
1,
have
2, 1, 2.
1, 2, 3. Okay, so then that's 1, 2, 3, 4, 5. This way, right? Or if we go the other way, that's 1, 2, 3, 4, 5.
Yeah, so like Brittany, normally like if it was a double bond, it would be bent right there. But because it's a triple bond, it can't bend.
That's
So
right.
just in your head, imagine there's a bend there and each side is the carbon.
Yeah. So and that's, I always get in trouble when I was drawing structures because I would always draw it as bent. And geometrically, you're not going to draw it as bent because does that make sense? It's a linear structure at that point. Okay, what about this guy?
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 2 octine.
Okay.
Octine.
Yep.
Okay.
Can I borrow a little bit of this?
I see that.
I'll put some of this in my coffee.
Four.
Thank you.
Okay, simple.
Yes.
Yeah.
So far,
I'm
Just
finally
gotta-
understanding stuff again.
Okay, so let's see if we can make it a little bit harder.
yeah, just wait.
Yeah, I'm just glad I got the base of this.
Okay, so you can have structures that have both single bonds, which we know single bonds, triple bonds, and double bonds. So there is a pecking order, right? So the guy who has the highest pecking order, and this is odd, it didn't make sense to me. It still doesn't really make sense to me, but it's one of the rules that has developed over the last couple of years since I took it. Your pecking order is going to be at the very bottom so far. Right, this we have alkanes is at the bottom. Above it, it's alkynes. And above those is alkenes. Okay. Now, what do I mean by pecking order? Okay. So the higher the functional group, they take precedence. They have priority over the other guy. Okay. Does that make sense?
So alkene has priority.
Yes, alkene has priority. The reason, to be honest, I don't know why. Because to me, I'm like, if you have 3 bonds, you should have priority over the one that has 2. That's my
Right.
opinion. But Iupac changed those rules a few years. Now I guess it's about 7 years or 8 years back, something like that. And they put the ene before the I. Okay. So, but when I took OChem, it was the other way around. So I'm kind of dating myself. Okay. Okay, so now in that context, then it is, say we have this guy. And do. And you always want the guy who has, well, you always want the smallest number on your functional groups, but you want the guy who has precedence have the smallest number it can have. Does that make sense? Or the guy who's the most important.
Yes.
Okay. And so the guy who has pecking order, the guy who's the most important, you always give them their last name. So since ene is more important than the ein, ene has precedence. So we should end with ene. And then I'll show you how to deal with the ein. Okay.
Wait, you said we have to end with ene?
Yes.
Oh.
1, 2, 3.
Okay, so with
Six.
you being the president and there's, 8, I guess I'm getting thrown off with that triple bond on the end.
Mhm.
So for the actual, when you're putting the front number, are you gonna base it off of the counting of the 1 from the lesser, or no, you're gonna count it off of the priority still counting from the left?
So you would count it so that the guy who has the most important have the smallest one. Okay. So if we started here, that's 1, 2, 3, 4, 5, 6, 7, 8. Now, if we started from the other way, that's 1, 2, 3, 4, 5, 6, 7, 8. Who's the most important?
That would be the
E.
double bond, right?
That would be the double bond, right? So we want to try to make sure our double bond has the lowest number. Okay.
So 3 octene would be for this one.
So it would be we would end it with 3 octene, right? Okay, so we need to also tell them that we have a double bond, right? I mean a triple bond. Sorry.
We just put
So-
a 3 at the end?
Yep. So the way that we say that there's a triple bond, there's 2 ways of doing it. The first way of doing it is by putting the number where the triple bond is at. Triple bond is located at 7, and then we put Y in. Okay, so that would be one way of doing it. So that tells me I have a triple bond on that 7th carbon. Or I can do it within the text itself. So I can go 3 dash. Actually, there's 3 ways. N dash ene. Okay. So then that tells me this guy refers to diene, and then this guy refers to the yn. Okay.
Ooh.
Oh yeah, it gets nasty.
What does YN stand for?
Triple bond.
Triple bond.
Like
The wine
Alkyne.
with that name, that Alkyne name on the
Yeah.
side.
So alkyne, remember? Alkyne.
Oh, okay.
Okay.
That second way to write it just looks strange because it's
Yeah.
like,
Makes sense to me because it's the first one to come up is 3 in the oct, and then 7 is an ein, but you have to end it with een.
That
right,
makes
but it's
sense.
just strange that they separated the word to throw in. Okay, whatever.
And you'll see it, and the worst part is that you'll kind of see it written both ways, right? Both of these, oh, let me see, that isn't true. You also see it a third way, where they will actually go oct 7.
Wait, the YN, that's the triple, right?
The yn is the,
Yes.
and you'll also see it written this way. So. And so this is what I like. I don't like. This is the more common way. This is the more.
Yeah, I like that way. That's a lot less.
It's cleaner, right? It looks a lot cleaner.
Yeah.
Okay. And so it makes sense because then you know that 3 goes with the E. But then
The
they'll
third
start
option
putting
makes
it
the
within
answer
the
look
text.
wrong.
What was that?
The third option makes the answer look wrong, but in reality, it's not.
And so you'll actually see it written 3 different ways, right?
Okay.
This is the one Iupac prefers this way, but these have been accepted ways. Okay. Which drives me crazy.
Wait,
And
real
I'll
quick.
show you why here in
like,
a second, right? Okay, what was that?
like I see how you got the 7 YN or whatever, like you count to it, but what about you just count, what side do you start from to count to the double? You start the
wanna
opposite
try to-
side of the triple?
You always want to go with the lowest number, right? To get to your main functional group. So if you want, it's
So
always
1,
best
2,
if you
and then
do
you
it at
count the
1.
bottom 3.
Yeah, so
Okay,
1,
I see,
2,
I see.
3, you know, and then, okay. So now what happens if I have 2 double bonds? Say we have one here, and we have one here.
Would you base it off of the lowest one?
You would always base it off the lowest one. Okay, so let's go ahead and count.
So 1 heptane 3.
2, 3, 4. Okay, so then this guy would be called, we would call this guy 1, 3,
1.
Heptene.
hep, hep, no, it would actually be hepdiene.
What?
Okay,
Dr. Henry.
Unacceptable.
Why dying, Dr. Henry?
because there's two of
Di
them.
Because
means
there's two of them.
Oh yeah.
Okay.
So now we're throwing back Greeks.
Yes. And so now we go back, yes, to the Greek prefixes. Di, tri, tetra. Okay.
Yeah.
Also, Dr. Henry, is that what oh, come on. In number 51 in the lab, is that what's going on in there with the
Yes.
dynamical-
Yeah. And that also is branching structure. We're getting there.
Well,
So I'm building you up here. I'm building you up here.
Okay.
oh Lord.
Okay. So how you doing so far?
Hang on, the 1, 1, 3. Because I see that hep with like it's the 7.
We put a comma instead of a dash after 1 then?
Yes. Because it tells you that you have 1, 3 hep dying. That means that refers to that dying.
Got
The
it.
only reason we're using the comma is because they're both double bonds versus
Yeah.
like we were using the dashes because they were different bonds.
So you're just pretty
Just the
much
double bonds,
it's telling you where the double is, right? So it's like it's on 1 and then like kind of where it starts.
That's right. Yep.
Okay. All right. You lost me for a second, but I'm back now.
Okay. So we'll try one more. We'll see if I can keep you guys. 1, 2, 3. And then we'll do double bond here, double bond here, and double bond here.
Man.
Okay.
So is that a 136 nonene? No, 136.
Non-tri?
Yeah, non-triene.
That's right. So that's 4, 5, 6, 7, 8, 9. Okay, so you said 1, 3,
Yeah, I see
6.
that.
Non-triene.
Okay. How you doing so far?
It's starting to make sense now.
Yeah, I'm starting to see
Wait,
it
hand
too.
roll.
I have a question.
What about I know the E, which is the double. What did the try? What's the try?
1, 2, 3.
There's 3 double bonds.
Oh, okay, I got it. I see it.
Dr. Henry, I have a question.
Yes.
So it only ends in E and E if there's a double bond present in the structure.
That's correct.
Okay. So
Yep.
if there's no double bond, it wouldn't end in E and E.
Yes. If there's only single bonds, then it would be an A and E. And then you
Okay.
wouldn't have to worry about the double bonds, right?
Okay.
Okay.
So then what takes priority when there's no double bond in the structure?
Well, in that case, nothing takes priority in that sense, right? So
So
if it's
okay.
if it's still a linear structure, because in that case, all you have to do is just 1, 2, 3, 4, 5, 6, 7, right?
Okay.
So there's nothing that has priority. So the functional group has priority. So if there's a triple bond and single bonds, then triple bond has priority. If there's a double bond and single bonds, then the double bond has priority. If there's a double and a triple, the double bond has priority.
Okay.
Okay.
So if it was just a triple and a single, the ending would be YN?
That's right.
Okay.
Y and E. Yep.
Okay.
Okay.
I see that.
Okay. So, you guys ready for the next part?
Yes.
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 I was born ready, Dr. Henry.
Okay. So, let's see. The next part is branching. Maybe, if I can get this. Okay, so you remember your priorities. We have Okay, so far. Okay, so okay, now when we have a group that's coming off the main chain, you always want to first find the main chain. How many carbons? What is the largest number of carbons that we can have? In this case?
6.
So he's already counting. 1, 2, 3, 4, 5, 6. Or if I count it the other way, that would be 1, 2, 3, 4, 5, right? So we want the longest chain always. We always want to find the longest chain. 6 carbon
Wait, how
chains
did
are
you
long.
just count that to 5?
What was that?
How did you just? Oh, you started the one on the.
I started over here in that branch, right? So I know that my branch structure here, right here, if I started here, that would only give me 5. If I went the other way, that would only give me 1, 2, 3, 4, right? So I know that my longest chain now is 6. So we know that it's going to have to end with, what is a 6 carbon chain?
Hex.
Hex.
Okay. So it's going to have to end with a hexane, since there's no double bonds or triple bonds in it. Okay. Now, this guy means that there's 1 carbon group hanging off. 1 carbon group stands, if it's only 1 carbon, then what would it be?
Meth.
Meth. So anytime that you have a branching structure, you'd use the term meth, and then you put YL at it. And you have to tell me where it's located at. So, and you always want that guy to be the smallest number possible. So it would
So
be
5.
3. Would it be, where is it located? 1, 2, 3.
Oh, you're starting from the side that you picked. That's okay.
3 methyl hexane.
Methyl.
So that tells me that on the 3rd carbon, 1, 2, 3, I have a methyl group hanging on. Okay, does that make sense?
Why methyl?
Yes.
Sorta.
Because there's only 1 carbon.
Only
that's
1
hanging off.
carbon.
Oh,
So if I have 2 carbons hanging off of it, let's say I have this guy. 2, 3, 4, 7, 8. And I have 1, 2, and this guy, 1, 2, 3, and this guy.
Ooh.
Okay.
that's way off, but all right.
Okay. So we want to first find the longest carbon chain. Number 1, first find the longest carbon chain. Okay. So let's go. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. Okay. Now that would be 9. If I went this way, that's 1, 2, 3, 4, 5, 6, 7, 8. Right? And then if I went this way, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right. Let's see, 5, 6, I'm sorry, 7 and 8. So that would be exactly the same. Right? So then my longest chain is going to be the one in the green.
Yes.
Yes.
Okay. Okay, so now in this case, the way that we would name it, we could name the longest chain. No name. Okay, now we have this guy has how many carbons off of it? This one here, off the second chain?
Just
One.
one.
1 carbon. So that's
Because
one
they're all-
carbon. So then
they're
that
all-
would be meth, right?
Will that be
Okay. What about this guy?
3?
It has 3, right? So this guy has 3 carbons. So we're going to put 1 here. We'll put a 1 with a circle, funny one. And then we'll put a 3 with a circle here. And then this guy,
2.
okay? So we want to try to give it to the one that has the lowest, in this case, the lowest number.
So it would be 2-methyl first.
So it would be 2-methyl.
Would that be the second one? Would it be? Ugh. 4-ethyl? Is it? Would it be 4?
That's right. 4-ethyl. And then
5-propyl?
that's right, 5-propyl.
Wouldn't it be 5-ethyl because it's at 5?
Nope. That's 1, 2, 3, 4, 5. This guy is propyl.
Oh, okay.
Oh, and then sorry, that would be 4-ethyl. That would be 6. Sorry, 6-ethyl.
So when
5-propyl.
we count like those branching carbons, would we use the longest carbon chain to figure out that first number?
Yes. Well, you want the longest carbons. The longest carbon chain with the lowest number to a functional group. So these side chains count as functional groups. They're lower functional groups, but they're functional groups. So you have a methyl here, so that would be after the second carbon. If we went it with the other way, we'd have something at the 4th carbon first. Does that make sense?
How come when we count these, we don't count like point of contacts? Kind of like how when we did the bonding. Like how come it's being 1 instead of it's technically an end and start point?
Because remember, you have hydrogens, right?
Yes.
Okay, so you started here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So each end represents a carbon, and that carbon is surrounded by it. Does that make sense?
Yeah, but I'm saying like the branches, like where the 1, 2, and 3 is.
Because that carbon here, this carbon right here, is part of the main chain.
Oh, so you can't count
You
it.
can't, then you're counting it twice if you count it that way. So you're just counting what's left over. So in this case, that's 1. And then in this case, it's 1, 2. Yeah. So actually, when we go with naming, the general rule is that meth, you want to start with your meth because it has 1 carbon. You go F, you're prop, right? That organization. Or it's done by alphabetical order, right? So that is the other way that is typically done. So when you're starting getting other functional groups, it's alphabetically. Okay.
Wait, so real quick, what was the reason for skipping the 5-propyl? Because wouldn't you just?
We didn't skip it. We have it in there, but we have.
Yeah. But like, I would feel like it should. You should flip the 5-propyl with the.
So there's trains of thought. So one of the trains of thought is that if you only are working with hydrocarbons, you put it in the order of the number of hydrocarbons. When you're starting to bring in other functional groups, other side chain functional groups, you do it alphabetically, right? Does that make sense? Okay.
Yeah, I see.
Because meth 1, F 2, prop 3.
Oh, okay. So you're in. Okay, so it's in order by. All right,
Yeah.
I see. Yeah, 'cause
So,
I was
but
wondering
when
why
you-
you would go past.
Yeah. But when you start bringing in those other functional groups, it becomes alphabetical. Okay, because then it's easier to count these times.
I have like a clarification question. So for those numbers in the front, like the 2, the 6, and the 5, those numbers when it comes to hydrocarbons, we're going to be using, in this case, the green numbers, which is the bigger
The
carbon.
longest chain. Yep.
Okay.
Yeah. And then that tells you what is going to be branching off. Yep. So does that make sense?
Yeah.
Okay, Brittany, you have that look.
I'm just processing.
You're just processing. Okay. Okay, you guys ready for one more? Want to try one
Yes.
more? Or do you guys got this? Piece of
No
cake.
more.
Throw in one
Let's,
more.
One more.
Let's name the structure on Brittany's wall behind her, whatever that is.
Hey.
Yeah, every time you're in a different room, where do you live? That is an interesting, like all your rooms have been kind of,
This is my living room wall.
Did you know you painted your living room wall 2-methyl, 6-ethyl, 5-propyl?
You're right. I sure did.
History is everywhere.
I was preparing for chemistry.
Oh my gosh. No, I understand this way more than I do the other stuff.
Okay, and let's do. Okay, how about that one?
Would it be, let's see, 1, 2, 3 dimethyl 4-ethyl octane?
Okay, let's see, you said.
I'm thinking it's 3-dimethyl 4-propyl octane. Or is that, wait, 1, 2, no, he's right. It's ethyl. 4-ethyl.
Yeah, because you counted the one in the beginning, huh?
Yeah, I counted 3. Whoops. Super
Okay, you
close.
said, now say it again.
Yeah.
2 dimethyl, or I'm sorry, 3 dimethyl.
3.
3. Okay, so now here you have to say exactly where it's at. So you would say 3,3 diethyl. Dimethyl. 3,3
What you mean 3-3? What do you mean by
3,3.
that?
They're both at the third position. Right?
Oh, you named both of them? But isn't that what the dimethyl is? Because if they were at different positions, wouldn't it be 3-methyl 4-methyl?
Yes, so it would be 3,4 dimethyl, right? Because you're only going to use that methyl once.
I see what you're saying. So if there was 2 methyls somewhere farther on the chain, you just put them together like 3,6 dimethyl or 3,6,9 trimethyl. But since they're on the same chain, you do 3,3 dimethyl.
That's right.
Yeah, I got it now. All right.
Octane.
Okay, does that make sense?
Yes.
So let's do one more for the road.
Oh, we got to wait in the chat. Is dimethyl because there's 2 of them. There's 2 methyl chains. Methyl is a 1-carbon branch. So since there's 2 of them, it's dimethyl.
1, 2. Yep.
If there was 3 of them, it would be trimethyl, etc. And he's doing 3,3 to indicate that both of those methyl branches, the dimethyl, they're both at the 3rd carbon on the longest part of the chain.
You mentioned the location, correct?
Yep. That's what the number is. It's the location.
Oh, okay. Yeah, that makes sense now.
Okay. What about the one in pink?
What about the what?
The one in pink. The new one I just drew.
Oh, I didn't even see it. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So that would be 3,
3.
4, 5, 3, 4.
Say 4 in Greek.
Would you say 4, 4 twice for location? Like would it be 3, 4, 4, 5 methyl?
Okay,
I
so
put,
that's 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? Did I count right?
Yes.
yeah, I
Okay.
got the same. I also
So,
got what Brittany
and
got.
you said
3,
3,
4, 4,
4,
5
4, 5
methyl.
methyl. What did you just say, methyl, or would you say?
Or no, I'm sorry. But sorry,
Tetramethyl.
tetramethyl. That one. Yeah,
Tetramethyl.
and then
Oh, tetra.
decane.
That's what it is.
Tetramethyl.
Oh, but
Decane.
what about
And then
6 ethyl?
what? And you said the
Methyl.
6
7
ethyl?
ethyl.
Is it 7?
Oh, I didn't see that last one.
And decane?
Decane. Yep.
But why is it tetramethyl?
Because there's
That means 4 of them.
4. There's tetra means there's 4 methyl groups. That's 1. I'll circle them in green.
Okay.
Okay. So that's 1. That's 2. That's 3. That's 4. Tetra meaning 4.
Okay.
Okay.
I mean, I think it makes sense. It's just it's one of those getting used to it things.
Yeah.
How do you name a circle?
Ah, you're just ahead of the game there, Nate. So, let me. This guy would be how many points do you have?
6?
5.
1, 2, 3, 4, 5. How many points do you have?
5.
So you would just say cyclo, and then a 5-chain carbon.
Pentane.
Pentane? Ah. Got it.
Okay. Now, if there's something coming off the branches,
Yeah, how do you
That
indicate what point to start at?
that will be 1. Wherever that branch starts at will be 1. So that would be 1 methyl cyclopentane.
Ah.
Will there ever be multiple branches off of something like that?
Yes. Yes, unfortunately. And then you just go with the functional group who has the most importance. So in this case, it's a methyl. Methyl, you start off with that one here.
Have you
Does that
ever
make
watched
sense?
Hamilton? Have you
What was
ever watched
that?
Hamilton's Pharmacopoeia? Have you watched a show called Hamilton's Pharmacopoeia?
No, I haven't.
He draws these, he'll do like whole compounds and he'll just draw these for like he'll go on and on while he's talking, just drawing what he's saying. It's pretty crazy.
Okay, cool.
I never
I'll have to take a
understood
look
why
at
he
it.
did it, but now I did.
Okay, so does that make sense though? Does that all make sense?
No, it doesn't. Because okay, you're saying that when one branches off, you'll go off of whichever one has precedence. But if you have all singular 111s around,
So you're saying in this case, if you have something like this,
That'll be 1, 2, 3, 4, 5.
that's it.
yep,
If one was longer, like if one had 2 branches, then you just
then it's the same thing, right? So if one had 2 branches, that work.
1, 2,
Yeah.
2.
So then in this case, you'd call this. How many methyl groups do we have? 1, 2, 3, 4, 5, 6. So you'd say 1, 1, because you could use the 1. It doesn't matter which one you
Put
choose.
it anywhere, right?
Yep, 1, 1, 2, 3, 4, 5. That's
So Brittany, you
hexa.
can name it anything because it's a circle. So whenever you draw it, it's going to look the same. So if you did like 1, 2, 3, 3, 4, 5, and you drew it, it would come out exactly the same.
Okay, and you
chemically.
just start at whatever.
Yeah.
If it's a circle, it has multiple branches. In this instance, I think you could just draw it anywhere and it'll come out the same.
Yeah.
Okay, I was just trying to say, like, does the point with more branches take precedence over the single branches or not necessarily?
Oh, you're saying, yes. So in the case of if it was a let's say it was a methyl, or I mean a propyl group over here, right? You'd want to give your propyl that 1 spot.
That makes sense.
Okay, does that make sense?
Yes.
I got you. There's
Okay,
one
so
of those
where-
on the nomenclature.
What was that?
There's one of these
What-
on the
so-
nomenclature.
So the 1, 1, is that the 2 coming off the same?
That is the 2 that's coming off the
So
same.
1, 1, and then the 2 would be,
Right here, 3, 4, and 5.
oh, so you're okay, so you're individual. Oh, I see it. I see.
Or you could have went the other way around. Yep.
Dr. Henry, is it supposed to be hexa or pent?
Yeah, that's what I was supposed to say too.
Penta. My bad. Thank you. Good eye. That's why I have to write them out in advance. Good eye, good eye.
Would it also be cyclopentane or just pentane?
It would be cycled. Good job. You guys are paying attention. See, I'm just testing you. That's what it is. Oops. If I could spell cyclo.
Go because it's a circle, right?
Yes. Yeah.
Cool.
Bless you.
Thank you.
Okay.
But
Any
what
other
about for
questions?
hexamethyl?
What's that?
What about for hexamethyl?
Hexamethyl. So because we have 6 methyl groups hanging off, 1, 2, 3, 4, 5, 6.
Oh,
Hexa, 6.
yeah, that makes sense now.
Okay, do you guys want to give it one more whirl now and combine everything that you've learned at this point?
Yeah.
Sure.
Okay.
Hey, just give me one. If you don't, just don't. Let me just write down this last. 2, 3, 4.
Oh my God.
What is that? The cyclo? I can't. It's mixed in with the.
Let me see if I can move this down.
Cyclopentane.
Okay, thank you.
Jesus.
Sorry, I started running out of room and then I just.
Okay, now you're good. No, you're good now.
Okay. Let's see. Okay. Let's do this.
Can you put all the cheats back up on the screen?
I will. Give me 1 second.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh man.
It's got a double bond.
Hey,
1, 2, 3, 4, 5, 6, 7, 8, 10. Double bond takes precedent over a single bond. So double bond beats triple bond beats single bond, like rock, paper, scissors.
Yeah, so double bonds beat triple bonds beat single bonds. Yes.
Okay. So it goes 2, 3, 1 if you're counting priority for bonds.
That's right.
2.
What is wrong with mine?
Oh, quick question. Would you, when you're naming it, would you name the bond, like the bond first or the branching carbon first? Or it doesn't matter.
I think branching, right?
I would put the branches first because it's what we did for the other ones.
Yes, branching comes first. Then you bring in the number of bonds. Then, yes. That's a good question.
Wait, how do we name a double bond again?
Ene.
Ene, E-N-E.
E-N-E.
Okay. I don't know if that's right. I think that's right.
That's the same thing I got.
But
Stick?
you would be missing the tetra, wouldn't you?
Where would the tetra be?
Oh,
On that
tetra.
first one,
Oh,
wouldn't it have been like 3,
Yeah,
4,
you're
4,
right.
7 tetramethyl
Oh, yeah.
2? That
I missed the tetra. Yeah. Come on.
Yeah, you're right. You're right. Blip. Thank you.
How do you know that tetramethyl goes first?
Because it's the only branches, so you put it first, and you put the branches first,
Oh,
not the chain.
Cyclohexene. So then we got one.
So for
One.
yeah, the cycle is throwing me off. So does where the double bond 1-methyl is that one like over where the single bond 2-methyl location is, or
So for that one, I prioritize the bond. So I set the start of the bond as 1, and so I put 1,3,3 trimethyl instead of 1,1,3.
Oh, I counted it backwards. I'm supposed to go shortest direction.
yeah, I was starting one from where that double little methyl
Count
section
it left
was.
to right, because my whole life that's how I've been reading things, left to right.
Because I just think for a chain, I think the bond would be more important, so they'd prioritize it.
Oh, that's where I messed up.
But we didn't. But in the first one, we said 2-decene, and technically 2 is the bond, but the 2 came after.
Wait, what's that?
Don't listen to me. I might be throwing somebody else.
Yeah, in the first one, the bond was the shortest, so that one was the easy pick.
Yeah, 2-decene. 2 is the location of that double bond, right?
Yeah.
Yes. Okay, so for up here, you guys got, what did you guys say? You said it was 3,
What's up,
4, 4,
4,
7,
4,
tetramethyl,
7. Tetramethyl.
2-decene.
tetramethyl.
It's kind of cold out today.
2-decene. Oops.
Tetramethyl 2.
Okay, and then here you guys got
I got
1.
1,3,3 trimethyl.
trimethyl,
Bruh.
1 cyclohexene.
1 cyclohexene. Okay, good job.
So I just have a quick question for the circle one. How
Yep.
do you know where to start counting?
The guy who has the highest priority. Right? So you always want to give
Oh,
the guy
for the
who has the
double
highest
bond?
priority, double bond in this case has the highest priority, right?
Oh, okay.
So you want to give him the lowest number.
Yeah, and if you start at the top, then you can give one of the methyls the lowest number as well.
Yep. You get a twofer. Okay. So how are you doing so far? Are you feeling good?
Better with practice.
It's
Better
making
with practice.
sense.
That's been the general sense so far. Better
Yeah,
with practice.
same here.
Don't worry, Dr. Henry gonna give us like 200 to practice on.
Yeah, I like giving you guys a lot of problems.
Don't worry, you're gonna get plenty of practice.
Let's see. Okay. So you guys ready to move on to the next part?
Yeah.
Okay.
Yeah.
So,
Sure.
so far we've only talked about hydrocarbons only, right? There are more things than hydrocarbons. Okay. We have other functional groups other than the hydrocarbon. And that's what I'm gonna kind of introduce to you. And then I'll have them, we'll start putting them in the order of priority, okay? And there's one of them though that is kind of, I'm going to show you two ways of doing it because there is the Iupac way, and then there's the old Iupac way, and there is the new Iupac way. The new Iupac way hasn't been adopted by any of the chemists, so that's it's still kind of being pushed through. Okay, so let me start off with the easiest one. Okay, so we've talked about the. Let me go ahead and put this down here, a little cheat sheet here. And then I'm going to put our priority list. I'm actually going to put our priority list on the other side because that's when it's going to start coming into effect. Things. Is your brain about to explode yet? Let me know when I'm getting there.
Getting pretty close.
I'm getting pretty close. Okay, so below these guys are always going to be kind of side chains. These guys, the next group is called alkaline halides. Okay. Alkaline halides, they have the lowest priority. What are halides anyway? Which group represents the halides? Does anybody remember? Halogens.
Isn't it the, I forgot what number, it's the seventh one?
17, yeah.
17.
17, yeah.
17. Okay, so group 17 are the halides. So that's carbon. I mean, not carbon, that's fluorine, that's iodine, that's bromine, astenine, right? So it's that group there, okay? So when we work with these guys have the lowest, they're the lowest of the lowest, right? So these guys always get something very simple added onto them. We're talking about and I'm drawing it out so you guys can see it right now, and then I'll show you how to draw it with, okay, so this guy here would be called 1,1-dichloro propane. Okay. So on that first carbon, we have functional groups, 3 carbons. So the way I would write it, okay? So if it's chlorine, then it's chloro. If it's fluorine, it's fluoro. If it's bromine, it's bromo. Sorry. Okay, so what would we name this guy?
Would it be
Would the first one be 1 chlor?
3
Right.
chloro, 5
3 chlor.
bromo?
So
Oh,
when
we
you
have to
do,
put together what we had before with this.
that's correct. Yeah. Okay, so what is the ending? What is going to be the ending? Longest carbon chain.
Octane.
Octane, yeah.
Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So we'll put the octane at the end.
And you have 3 chloro and 5 brolo.
Okay. So I have 3 chloro.
Brolo.
3.
So we have a 3 chloro. Okay.
Bromo.
We have where's the bromo? So
Oh,
we
the
said
bromo.
5 bromo.
5 bromo.
Bromo.
3 chloro.
And then is it
And
you would
there's a
name your methyls, right? So,
Mhm.
4,4 methyl, right?
So how many
it'd be
methyls?
there's
Trimethyl.
3 methyls.
There's
Oh,
3 methyls.
trimethyl. 2, 4,
I'd
4
have
tri.
Yeah,
2,
2,4,4 pro
4.
trimethyl. Yeah, sorry.
2, 4, 4 trimethyl. 5 bromo.
So
3
these are the
chloro.
ones that would in alphabetical order.
Oh.
That's right.
Jesus.
Hang on. So how do you? What makes it in? Oh, so just you looking at the B and the C
That's right.
to put it in. Okay. All right. All right.
Yeah, you don't look at the prefix. You look at the what it actually is, the function.
You almost lost me there for a second, but
And because it's a bond, we list it before the branches, right?
That's right.
Makes sense.
Yeah, Brianna, I think this is the alphabetical ones.
Yeah. Yes. Yes. So the order does matter. So you want to put it in alphabetical. So now these are other functional groups that we're taking into consideration. So we want to start putting them in alphabetical order. Okay.
so would you get it? Yeah, so it'd be wrong if they weren't.
Technically, it would be wrong. Yes. But will I mark you off on it? No. If you were in my general chemistry class, yes.
Wait, what are you marking us wrong for?
Alphabetical order.
Oh, that's how you do it? You do it in alphabetical order?
That is correct. B, C, M.
Ah. So this doesn't have to do with priority anymore.
No.
It's-
Yeah. At this point, you're going to go with alphabetical order.
Okay.
Just to clarify, if say, because you just said BCM, so if it would have been instead of methyl, if it would have been, I don't know, let's say butyl whatever. So that would be the second one. It would have been before the chloro.
No, it would still be M because it's the function. Looking at the functional group, that would be.
No,
So we
I'm
did-
sorry. I didn't mean methyl. I meant if there would have been
Oh, you're saying if it
like
was like
before
butyl. If it was butyl,
yeah.
yeah. So if it was butyl, it would be between the bromo and the
So it'd be 5-bromo, 2,4,4 tributyl,
yeah
3-chloro, like that.
yeah.
And then octane is always at the end, regardless of the alphabet.
That's right. Yep.
All right.
Because that's like it's the last name, the most important one, right? Longest chain.
Is that how everyone does it?
Yes.
Like the alphabetically wise?
Yeah. So that's the way Iupac. It wasn't at first. It was done by priority. That's the way that they used to do it a long time ago. And to me, that was a lot easier for me to remember because then you learn the priority and you kind of stuck it in that priority. But then they start doing it by alphabetical, right?
What is the priority in regards to? Priority in regards to its combustibility or its bonding capabilities?
You know, in all honesty, the priority I think has to do with the complexity of it.
Okay.
But I'm not 100% sure because there's certain ones that I know that are a little more complex than others. But you know, you just learn
That's why
that there's a
agreed to do it
priority.
by alphabet because it's not that important basically. So they're doing it alphabetically.
Yeah.
All right.
Well, because
Gotcha.
but then in terms of priority, in terms of naming things, they have a little rule that you go by, right? And so
Right.
and then so I'm just kind of building you guys up to that rule. Okay.
All right.
Okay.
But real quick, just to clarify, what is the trimethane again? The
Trimethyl.
tri is the
It's how
trimethyl,
many methyl groups we have, right? So if you look here, I'll circle them in red.
Yeah. See how it says 2,4,4? There's 3 of them.
1, 2, 3.
Oh,
You see
okay. Yeah, because what was throwing me off is I was counting the bottom ones too.
No, so those are
CL.
attached. So that's a bond between the carbon on the main chain and Cl.
Yeah, so
So
those
that
are
just
just two
represents-
different. Okay.
All right. What happens when you got a branch off of a branch?
Do you really want to know that? Right.
Well, we
Then-
have to because the homework
for-
has.
Actually, it doesn't have a branch off of a branch. You don't have a branch off.
Okay, it's
Oh,
okay
I-
then.
But in the case of that, what you would do is you would name the branch, and then the branch also have an ene associated.
So it become its own chain.
That's right.
All right. So you kind of deal with it each as an individual chain, like an
That's right.
individual chain going this way, individual chain going that way.
Yeah.
All right.
Yeah. But in most cases, also there's kind of like the way chemistry kind of works. Again, you always go with the longest chain, and then they'll give certain types of branches, special names.
Right.
Because there's only so many ways that you can actually get that polymerization of those carbons. Or the
Kind of
addition.
like how our polyatomic ions are already named, like they're already grouped together.
Yeah. Yeah.
All right.
Okay. So how are you feeling about the halides? Pretty simple. You want to try one more?
Mm,
No, are you good? You're good?
No, one more.
I want to try more. I just don't. When you said how are we feeling about it, definitely want to try more. I don't know how I'm feeling right now. I feel like I'm gonna cry. That's how I feel. Is that it?
That's it. So I'll just, since you're calling me out, then I'll just add a
Oh no, it's all right.
Really, Nate.
I just thought it was gonna be. I didn't. That's not what I meant. All right. Let's see. No, it's good. It's good. Hey, I'm already top 6, baby. Okay, you know what I'm saying. I'm worried about you guys. All right. Let's see. Cyclo. 1, 2, 3, 4, 5. Cyclo. Pentene. Cyclopentene. Which way do we count?
And by the way, you guys are all asking the right questions. You guys are doing a good job of asking questions. Keep asking them. You know.
All right, so we got 1.
All
Chloro.
right, so I got 2 chloro, 3,3-dimethyl cyclopentene.
What do you have to put the one cyclopentene?
I don't know, because he said about priority. Does that double bond? Is
Oh
that
yeah,
where we?
yeah,
No, like two
One
chloro,
cyclopentene.
3,3
yeah. Sorry, I was just
one cyclopentene.
I was just in like the one is invisible, so you don't have to say it mindset for whatever reason.
2 chloro.
So you guys sure?
I'm sure.
I was gonna start 1 chloro and go 2 methyl, but I think they're
You
right.
have to always say it because it's location.
You're gonna have to say because of location. So, but think about what we're
If we started chlorine, then the other bond. We would
do the
go.
counting. That's what I'm saying. You got to do the counting.
If we start at chlorine, the double methyl bonds would be at 4. If we start at the double bond,
Who has priority?
I thought double bond
The
had.
double bond has priority, so you
That's
have
Double
to
what
bond
one
has
at-
priority, so we want to make sure that it has the lowest number, right?
Yeah, so it's 1 cyclopentene, and then 1 chloro or 2
cyclopentene
chloro.
at the end.
Is it 2 chloro? Are you sure? That's what I'm questioning you on.
Yes, because if you do 2 chloro, then that means the methyls are also closer.
Okay, so let's do that count, right? So you're saying if this is 1, right? You're saying here, that's
Yes.
1,
Dimethyl.
2, 3, 4, 5. I should probably put that in a different color. Right?
Yeah, I'm
Right, but
counting,
we're counting backwards though, right?
I'm
Or
counting the other way. I'm counting 1.
then
Yeah, I'm
that
counting
would
the
be
other
1, 2,
Oh, snaps.
3.
You got to count at the bottom of the bond.
4, 5.
Oh, okay, yeah, that makes
3
sense.
chloro.
Because
3
the
chloro,
bonds-
4 dimethyl.
Wait, so why couldn't we count one from the like top
Because
right there?
the bond's not
Starting-
going that way.
Because the bond's
right.
2-sided.
Yes, remember the bond is two-sided, so you want to go where the bond is starting, right? So that would be the start of the bond. If we say 1, then that would be 2, 3, 4, or we'd have to start here, 1, 2.
You
Does that
can't
make
go
sense?
1. If we were counting 1 and then going away from the double bond. So that will put the double bond at the end.
Yeah, okay, that makes sense.
1. Okay, 1, 2, 3 chloro.
So then it's 3 chloro, 4 dimethyl, 1.
That's right.
Cyclopentene. It's cyclopentene, right? Like ENE.
Yeah.
Yeah.
Woo.
So you thought you were like, oh,
Right?
that's an easy one. There's a neighbor was like, oh, that was an easy one.
Hey, I didn't say that, man. I just said, are you done? Are you finished?
But the implication was,
There was no implication. It just, you're all, we're gonna try one more. And then you drew a little square. And I was like, is that it?
he's like, yeah, give me something that's gonna be hard.
Hey, it worked out good. It was a learning experience for the class, okay?
Yep.
Oh my geez. I gotta put dashes. I keep forgetting dashes. Pentene. Oh, have you graded the second test yet?
No, I haven't. I had 2 more people that need to take it, so I want my answer out there.
Oh, it's pentane. I thought it was pentene because of the double bond.
It is Ian.
Ane would be if it was all single bonds, right?
That's correct.
All right.
Like what our answer would have been if someone did that.
Oh, whatever, dude. Yeah, I helped
Okay.
you learn. Okay, on the test, Brittany, you could thank me later when we get this exact answer.
Probably right.
Okay, so let's add another functional group.
Rolo.
You see,
Rolo.
I'm never gonna not name Bromo right now because of Brolo.
Brola. Okay.
Oi.
Okay, so now we have our halides, our alkaline halides.
How you doing, Ryden? Ryden.
So we just put that O at the end, right? So I'm just going to use an X dash O. Alkanes. We have alkene.
They said alkyl halides end with XO.
What was that?
Alkyl halides end with X and O.
No, they ends with O, like chloro,
Oh, just
bromo.
O.
Yeah. So the X just means anything, right? Okay, and then we have you're going to ask me why I'm doing this here in a second, right?
Yeah, I was just about to ask why are we ending it more shortly.
Okay. Because there are other guys that have more priority. Okay. So our next one is going to be amines.
Like aminos?
Yep. That's right. So so this here, say the back part will be the suffix, the prefix would be amino. Right. Like your amino acids, right? Okay. Okay, so the generic form for amines is N, and we're going to use this R. R means hydrocarbon. So there's two types of amines. This guy is called a primary amine, meaning there's only one hydrocarbon. You can also have a secondary amine, meaning two hydrocarbons, or a tertiary amine, meaning three hydrocarbons. Okay, So we have this guy. We would name this guy trimethyl amine.
What groups fall under amino or amine?
What makes it an amine is the nitrogen.
Okay.
Okay, and it has priority over all of the guys, right? So if I have, say, this guy, so 1, 2, 3. Okay, so this guy would be called, it's bad, I drew it and I can't even see it now. One, two, three.
So do we count through the end or do we stop at the end?
What was that?
Like, you know how the end's in the middle? So does that chain go on the picture? Does that chain go through when you're counting, or does it stop in the middle where the end is?
It stops where the end is, because the end is kind of like, it's the nuclear, it's the bond that's attaching all the hydrocarbons. So it's not like you wouldn't count your chain. You would go 1, 2, 3, 4, and then come over here. It stops at the end. This here is the bond with the end. Does that make sense?
Yeah.
Okay. So if we count it, this guy is 1, 2, 3. This guy is 1, 2. This guy is 1. Oops, wrong color. 1, 2, 3, 4. Okay. So if we went alphabetically, so this guy is pro, this guy is bute, this guy is eth. So we would go start with the bute. So it'll be butyl. 1, 2, 3, 4. Okay. Then it would be ethyl. Two, propyl, propylene, propylene, amine. Oops.
On that first one, I mean, it wouldn't have made a difference if you counted 1, 2, 3, forward or back, but normally on our writing, because of where the bond is on that the top little section,
Yeah.
wouldn't we technically count from 1, 2, 3 versus 3, that 3, 2, 1?
But
Wait,
you're always going to start your 1 is going to start nearest to the most important functional group. Right?
And the nitrogen is more important.
Yes, nitrogen is more important. That's why we give it its last name. And then you'll notice that I put that YL, but I put the ENYL to let me know that there was a double bond on that branch.
Okay, so it's not ane because amine has to take that last spot, so it's en.
That's right. That's
Okay.
right. Okay, because amine has priority over ene, over the alkene. Amines are more important. Okay. You got it so far? You ready to give it a shot? Yeah. Okay.
Wait, I don't know what. I'm still confused. How'd you get a propanil or the prop part?
Okay,
got-
because there's a double bond on the second carbon off that chain.
Okay.
And so if you guys look here, this here represents, let me fix it real quick. Hold on. So when they have priority, they get the suffix. Suffix is at the end here. And then when they don't have priority, they get the prefix.
Oh, okay, yeah. I was
Okay.
just blanking when I saw the prop and I looked and I thought it was 4 for some reason. That was just me blanking.
That's right. Okay. Okay, so let's see. And that's why. And I should write both actually. It's EN. Okay. Good. Okay. Let's see. Let's do this one. Okay. That's an H. Okay, our blue structure. That's what we're naming now.
I got hydro. No, wait. Would be
Now, if it's just the H, you're not going to include it. That's taken into account in that amine.
Oh yeah, okay. So then it would be hexylmethylamine.
Okay. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 1. Okay. So then you said it's hexyl.
Oh, never mind. Then it would be pentyl with 5.
Okay. Pentyl. Okay.
And if it's pentyl, then wouldn't methyl go first since? Yeah.
Methylpentyl.
Amine.
Okay. That's it.
Methyl goes.
It tells us where the double bond is at. So that EN represents the double bond. And so it just tells us where that double bond is.
That was more so a word. How did we get a P in the middle of the pro and the N, the O name on the first one?
This one down here.
How did we place that P 3 is just pro, and En is for alkene. How do we get the P?
What do you mean by how did you get the P?
In the middle, like, so it's PRO, right? And then En. So PRO is for the 3, and En is for the ene,
Double bond.
the alkene, right? But what's that P like in front of the En? You not see what I'm looking at?
Okay, it's actually, so that pro is, it should be propane, sorry. It should be propane. That should actually be,
Oh, it's the whole word. And
Yeah,
so,
my bad.
okay.
My bad, that should be, there we go.
Oh, okay.
Yeah.
I was confused.
Okay. How you doing so far?
I'm fine.
Okay.
Just mixing up the rules in my head because there's so many today.
Yeah, I'm gonna have to call it, Dr. Henry. My brain is full. I'm gonna.
Okay. Well, I got one more, and this is the one that I think you guys are going to do after this lecture.
All right, I'll stay for one more, but my brain already went on vacation right after the last part, so I'm.
Okay, so let me pull these get together real quick. Okay.
Can we do a top? Can we do a top 15 instead?
Top 15. Okay, so our next one is alcohols. See, our list is getting kind of big here, right?
Is this going to be is there a printout for all these for the test? Because I didn't see it in my package.
I'm going to add it onto the resources. So.
Yeah, I'm going to need to print that out. Both show.
Okay. Come on. There you go. So, okay, so we have alcohols. So for alcohols, the prefix would be hydroxyl,
Hydroxy.
And then the suffix would be all.
Like methanol?
Methanol, exactly, like methanol. Yep. So when we talk about alcohols has higher priorities than all the ones that we mentioned right now. So that's 1, 2, 3, 4, 5 carbons. And then that OH means that it's an alcohol. So then this guy would be named 5 carbons.
Pentane?
Pentanol. Since they're all single bonds, it would be called pentanol.
Oh.
Okay. Now, this guy would be fine being called pentanol because it's understood that that alcohol is on that first carbon. Now, sometimes that OH group is not always on the first carbon. 1, 2, 3, 4, 5. Okay, and this guy here would be called 3 pentanol. So that tells me that the most important one is on the third carbon. It's a 5 carbon chain, 1, 2, 3, 4, 5. This guy would be called 3 pentanol, or it would be called isopentanol. Iso meaning the same, but you have the same number on both sides.
in this case, if it was like not an even, like right, not in the middle, if it was like a hexanol and it was on 3, would you count it from left? Like, would you count to get to
The lowest number. That's right.
the branch?
Yep.
So you
So
count it from
one-
that direction.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6.
Okay, instead of, so it's the same rule. All right.
Yeah. Exact same rule. You always want to give the guy who's the most important
The lowest number.
lowest number.
All right.
Okay. Okay. Pizza cake.
Yeah.
Okay. So this is what you guys drink. Oops.
How you know the chemical equation for Yoo-hoo?
How do I know the chemical equation for Yoo-hoo?
How you know what I'm drinking?
Mm-hmm.
So that's 1, 2, 3 propanol. Oh, so it's just propanol?
Or is it just the
1,
2?
2. Right.
Oh,
Because remember
third-
that carbon is attached to that oxygen. So
Oh, so it's ethanol?
this is ethanol. Yep. So drinking alcohol.
I thought that was rubbing alcohol.
Nope. Isopropanol or
Oh yeah, that's right.
one, two, three, isopropanol or rubbing alcohol.
Is it iso because it's directly in the middle?
That's right.
Okay.
Both sides have the same thing.
So ISO, you can say is balanced.
That's right.
Hmm. So ethanol, that's the alcohol in like alcoholic beverages that gets you drunk?
That's right.
I didn't know that.
That's what's in beer and wine and whiskey.
I don't know. I don't drink, so you got me there.
Sure. And my name is Fred.
I'm a bartender. I don't drink, man. It's like a drug, it's like a drug dealer that doesn't do drugs. You know what I'm saying?
Exactly. That's my point. That doesn't exist.
I go to the bar and I take everybody's money, man. I don't spend it on alcohol.
I didn't tell you about the name of my art kit for college.
What's that?
To get through college, that's what I did. It's one of my many jobs.
Yeah, me too. And now I'm still doing it.
It had its really good days, let me tell you.
It does. But I thought I was just gonna do it through college, but then I ended up being in college for 11 years. So in community college for 11.
It might be directly proportional to the time that you're spending at the bar there too.
Maybe that's what it is. I never looked at it like that.
Okay, so how are you guys feeling so far?
Not horrible.
Not horrible?
Fine.
I feel better about this than the last thing we did. The
Oh.
nomenclature.
Definitely.
By tenfold.
What is this called? Is this still part of nomenclature?
Yep, this is all part of nomenclature, but this is organic chemistry, right?
Yeah.
So inorganic, we have inorganic, we have organic. And so there are two, what you guys are learning in general chem is primarily inorganic, but you need to know a little bit of chem so that you guys will be able to write the structures for organic chemistry like ethanol, ethane, propane, so you need to know a little bit because we still play with those chemicals. So I wanted you guys to get some of it underneath your belt. Okay, I have two more to give you, but I'll give you those on Thursday. Is that cool?
Yeah, that's very cool.
That's yeah.
Okay, and then you guys, I'll be putting this functional sheet up mine got cut off a little bit. Some of you guys already have it as part of your packets. And so this is part of the things that you guys can use, right? And so it has all of the functional groups used in organic chemistry, right? But you're not going to have to learn them all, but you need to be familiar with them, be able to recognize it.
All right.
Okay, and that's on the back of your
Oh,
on
show.
this. Okay, so Harnell, I'll be putting it up into the resources page right in a few minutes.
Yeah, the lab, I was looking at it. It doesn't look like what we were doing today.
No, the lab today, well, actually, it is sort of what you've been doing today, but it's applying all the things that you've learned because you've already learned how to balance equations. Now you're learning how to read and write the chemical equations. So let me pull it up.
Well, it says like the first question is iron reacts with oxygen to form iron 3 oxide.
Mm-hmm.
So
So then
we
you
just
should be able
the
to,
equation for iron 3 oxide.
so no, you'd write the equation for everything, right? So let me pull up the lab so you guys can see what you're saying.
I'm still recovering from the last lab.
You make it sound like they're horrible or something, you know, like
Bro, they take forever, man. I got other classes. It takes me hours to do these labs, man. Hours.
well, that's what it's supposed to. So it should take you at least 4 hours or 3 hours.
Well,
At
when my
least
baby
three.
mama dumps me, Dr. Henry, you gonna help me watch the kid?
I'm doing it already. You know, it's like you have no idea how many kids I watched over the time that I've been teaching. How many divorces I've caused.
I hear you.
Okay.
She's like, get off the damn computer. I'm like, I can't. I'm drawing branching structures. It's only
Lab
my
6 wasn't
50th
due
month.
yet, right?
No, it isn't. Lab 7, you mean? Lab 7? Lab 6 was already due. Lab 7
Not
was,
6, I mean 7. Yeah, the
yeah.
nomenclature
No,
one.
it's due Friday. Okay, so like this one here, it says iron reacts with oxygen to form iron 3 oxide. So then we know that our reactants, who are our reactants? We're going to underline them in green.
Iron and oxygen.
Iron and oxygen. So we know that the symbol for iron is what?
Fe.
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 Okay. Is iron diatomic?
No.
Nope. We know that iron is a metal, so it's going to be a solid. We know that oxygen, what is the chemical symbol for oxygen?
Oh.
O2 for that.
O2, that's right. Because we know that oxygen in its natural state is diatomic, and it's a gas. And then it forms or generates or makes iron 3 oxide. So what is the chemical formula for iron 3 oxide?
Fe2O3, right?
O3.
There we go. And that's a solid.
That balances out.
So is it balanced?
No, you're gonna have to balance it.
Okay, so we have to balance it. So that would be our next part. So how will we balance it?
You know that oxygen is a -2 charge, and you have 2 of them, and then
So we have this. No,
oh, just no. Sorry, I'm thinking about
balancing the
it.
chemical equation. Yeah. Okay,
What are
so
you
how
doing now?
many?
So you have 1 iron
2.
on one left. On your reactant side, you have 2. On your product side, you have 1.
I
You
would
mean
actually
3?
just
Oh, we're balancing them. Oh, I got you.
Yeah,
I got
that's
you.
why I was thrown out to at first.
so for this equation, I would actually just put a 2 on the product first.
Okay, so then that would give me
4
4.
iron and 6 oxygen.
okay.
And then you can just easily balance it by putting a 3 in front of iron by itself and a 3 in front of
A 3 in front of iron.
a 4.
Okay.
Is this Edgar talking? I bet you it's Edgar talking.
Of course.
Edgar, they're gonna hate you. You realize that, right?
Edgar, stop speeding through the problems, bro. We don't know what's going on, Edgar.
Well, it's just whenever you're doing a chemical equation, just always balance the single ones last because it just makes it easier.
What's the single one here?
Oxygen and iron, they're just solo elements by themselves. So since the product is a molecule compound, and you know it's uneven, you make the uneven numbers even, and then the rest just falls into place.
Yeah,
Um,
what he said.
Exactly, yeah.
make the uneven numbers even.
The first thing I do whenever I see a chemical equation, I look at whatever elements are by themselves. And in this one, it was really, really easy because an entire side of the equation is just elements.
Yeah,
by
then you can
themselves.
just manipulate. You can manipulate the one side of wherever you want it to be.
Hey, don't be condescending, Edgar, with that really, really easy talk, okay? No, I understand what you're saying, bro. Thank you.
Okay, so let's do number 8.
Wait, so is that done then? 2
Yeah, that's
Fe2O.
it. It's
That's done.
balanced. All right, that's all you need to
That's
do is
how you
balance
want
the
us to write
equation.
it for our lab.
Yeah. That's it.
So it's okay for us to write these labs out, right?
Yeah, yes, it's okay for you to write them out.
All right, just do it 45 times and then it's it. Okay.
Is it only 45? I cut it off. I should have added another 100.
I don't know. I didn't look at it. It's something like that.
Okay, so let me fix that. I'll add the other 60 or so.
Hey,
Oh my God. My bad, my bad. Is this like the cyclopentene again, all over again?
Okay, so number 8.
So first off, you would have CuSO4
Says CuSO4.
times or dot or whatever that sign's supposed to mean.
Pentahydrate. Oh, that's it. Times
Five.
H2O.
5H2O.
5H2O. It's heated to drive off the water. Just draw an X through the 5H2O. Boom, done. Next.
No, it's a chemical reaction. You got to sit there and tell me what is going to happen then.
Add heat.
You just separated, so instead of having a black dot, it's just plus.
That's right.
I would have been a mad chemist for sure.
Well, you're already getting to that point already, so you're working your way there.
I would have been an alchemist, a mad alchemist.
Okay. Simple.
Yes,
that's the answer.
That's the answer.
because
The part I had to drive home on.
yeah,
Because it says in the thing, it's heated to drive off the water. So that's like the product before the reactant. It's like backwards.
That's right. And so the key is that you always have to remember conservation of energy or conservation of matter, right? Conservation of mass. So what you put in, you have to get out. So if you're driving off the water, H2O is going by itself. And then what's going to be left over? Your copper sulfate, copper 2 sulfate. Okay. Piece of cake. One more for the road, and then I really have to go because I have to grab some food or some more food. So let's do 9.
Still in class. Chlorine gas reacts with sodium iodide. Did you bring home donuts?
Cl2.
Girl,
Took them to work this morning, hoping everybody would eat them.
I'm trying to lose weight. Oh, so you try to get donuts before work? So I didn't know
Plus
you.
NAI.
I see how it is.
I tried to get rid of them.
Oh shoot! Hold on.
Now we heard all your donut talk, Nate.
My bad.
Yields.
My girl brought home donuts.
Okay. So in this case, you have a single replacement. So we have a halogen, and then we have a metal and a halogen. What do you think is going to happen? Who's going to replace who?
Chlorine's going to replace iodine.
That's right. Chlorine is going to replace iodine. So we're going to end up with NaCl. And is iodine a diatomic?
Yes.
And when's this one due?
Next Friday.
Okay, good.
The 23rd.
All right, good.
Okay, is it balanced?
No.
Okay. Okay, what do I need to do to balance it?
All right, let's see. Oh, you saw the picture of Ryden going to school today?
Yeah.
Yeah.
Since they're all kind of mixed up, you can't really isolate one by itself. So I would just go down the list. That's just how I do it. So I'd balance chlorine first.
Okay. So put a 2 here. Is that what you're telling me?
Yes.
Or I just guessing? Okay. And then
Would that be 6 chlorine because of the subscript 3?
that's
Yeah,
a,
what's up?
yes. That's not a subscript.
That's just saying it's a solid.
Yep.
And now I'd balance sodium on the other side, since sodium is the only one that's in a compound on both sides. Looks balanced now.
Okay. Okay, questions, concerns, Cash. Piece of cake, strawberry with chocolate
Professor
frosting?
Henry,
Yes.
for the Na or how does it go to Cl plus Na I to NaCl? Like how does it combined again?
So what you're doing is you're doing an exchange, right? So your Cl is being exchanged for your iodine, so they're replacing each other. It's kind of like you're dating this girl, and she's kind of trashy, and then you find this other girl who's really classy, and then so you're exchanging. You know?
Oh, okay. So
Okay.
for all these, there's gonna be like some sort of exchange.
That's right.
Oh,
Single
okay.
replacement. Yep.
Gotcha.
Or single displacement. Yep.
NaCl is a gas or a solid?
Cl2 is a gas. I2 is actually a solid. So as you get heavier or as you get bigger, you become more solid. So like for instance, bromine and iodine are both solids, but Cl is still a gas. Fluorine is still a gas.
Are
And-
we expected to put those subscripts for physical state on all of the equations?
You should put if you know them, put them. Get in the habit of doing it because it's going to be important at certain points. So when we get into kinetics and stuff like that, that plays a part. What happens, and how you determine the rate, right? So for instance, your solids don't typically affect the rates. Solids, liquids, because when you're doing reactions, you're only touching the surface, right? So then they have no effect on the rate, where the gases do. Gases, aqueous, they do. Does it make sense?
Yes, it does.
Questions, concerns? Cash?
When's this lab due?
This is due next Friday. But I wanted you guys to get started on it because it's really using all the things that you're learning still, that you're learning that nomenclature, right? You're actually starting to apply it. And you're applying the things that you already know, balancing equations, right?